All right, everyone. Hello and welcome to the third screencast of Chapter 4 on elasticity. And in this screencast, we're going to be talking about graphing the own price elasticity of demand. And I forgot here to put this in the slide, but yes, it's the own price elasticity of demand that we're going to be talking about. So the price of pancakes changes. How does the quantity demand of pancakes respond? What is the magnitude or the sensitivity of quantity demanded to the change in price? So in a few screencasts, you'll see why I've been so insistent that we call it the own price elasticity, because there's going to be a different kind of price elasticity of demand. I want to make sure it's very clear which one that we're talking about at any given time. All right. So in this screencast, we're going to graph the own price elasticity of demand. All right. So if demand is relatively elastic, then we are relatively sensitive to price changes. The demand curve is going to be relatively flatter. If demand is relatively inelastic, we are relatively insensitive to price changes, and the demand curve is relatively steeper. So we're going to graph this and take a look so we can see why this exactly is the case. So let's take a look at this on a graph. All right. So here we have a person, when the price is P0, they demand this much. When the price is P1, they also demand this much. So this is the perfectly inelastic case. In the perfectly inelastic case, the demand curve is a vertical line, all right? And what happens here is that the change in quantity demanded is 0. So 0 divided by anything is 0. So the elasticity of demand is 0 when someone has perfectly inelastic demand. Any change in price, be it an increase or a decrease, does nothing to their quantity demanded. All right, it is completely insensitive. All right, so let's no change. So let's look at another case here. Here is a case where we're going to have price start out at P0, then we're going to increase the price to P1, and we're going to see that the change in the quantity demanded goes from the quantity demanded here at P0 to this quantity demanded here at P1. So we have a large change in the price and a small change in the quantity demanded, right? So notice, small change in the quantity demanded, big change in price, all right? This is inelastic, relatively inelastic, all right? Big change in price, hardly any response, all right? This next case we're going to see, so let's change the price from P0 to P1, all right? And notice we have a small change in the price and a relatively large change in the quantity demanded. There we go. Put that in there, okay? So when you have a big change in the quantity demanded and a small change in price, all right, this is elastic demand, all right? The response is bigger than the change in the price is a way to think of it. And if you remember from the percent change formula, that's exactly what it is. The percent change in price is smaller than the percent change in quantity demanded, all right? And so this last case, we're going to look at a case where the demand curve is horizontal, all right? So at a price of P0, this person will demand an infinity of this good, all right? Because this demand curve doesn't stop. It just keeps going on and on forever. And the way to think of these perfectly elastic and perfectly inelastic cases may be, especially with the elastic case, of thinking of like a limiting case. So you never quite get to perfect elasticity. It's just kind of the limit as to how far things could go, all right? But notice what happens here. I go from demanding an infinity of the good, going on and on forever, to demanding none of the good. If I increase the price, then this person suddenly demands 0 of the good because I never cross the demand curve. And what's happening here, and again, don't tell a math prof that we're dividing by 0 because we'll rip a hole in the space-time continuum, but we're basically saying that the percent change in price can be infinitesimally small, just fraction of a penny, and quantity demanded changes completely. It goes from 100% to 0 all at that moment that you do that, all right? So how do we remember the own price elasticity? Relatively shallow or flat demand curves are more elastic. Relatively steep demand curves are more inelastic, okay? Ways to remember this: steep demand curves look like the letter I, so they are inelastic, all right? The steeper they are, the more inelastic they are. steep demand curves have an almost infinite slope, as in I, as in inelastic. Okay, so here is it's kind of summing up some of the stuff we've said so far. So if something is perfectly inelastic, then its elasticity is 0. All right, the price does not matter. All right, so that could be something like saving your pet. You'll do that no matter what. Another example that people often use are getting life-saving medicine. Right, you have inelastic demand for that life-saving medication. You would pay whatever it takes to save your life. What is relatively inelastic? Well, this is elasticities that are between 0 and -1. All right, price is less important than the quantity demanded. All right, so something like this would be like electricity. So yes, you respond, your quantity demanded changes when the price goes up, but it doesn't change by the same magnitude because you've gotta have it. All right, unitary elastic goods are where there's a 1-for-1 in terms of this percent change. So the percent change in price and the percent change in quantity are the same. So they are equally important. And then the last is where you're relatively elastic, and that's where when you're between -1 elasticity and -infinity. Price is now more important than quantity demanded. So for something like an apple, if the price goes up a little, maybe you'll switch to another fruit. Maybe there are lots and lots of substitutes. All right, and then perfectly elastic is where you get to a case where price is everything. So say for like a $10 bill. How much would you buy? If the price of the $10 bill was less than $10, you'd probably buy as many as I would sell you. All right. But if it was more than $10, you wouldn't buy any at all. And again, that perfectly elastic case, it's best to think of it as a completely limiting case because we never really usually get perfectly elastic goods. All right. So that, oh, one more thing, time, elasticity, and the demand curve. All right. So lots of things have short-run demand curves that are inelastic. All right. So housing in an area is often inelastic. If the price changes tomorrow, there's going to be no quick change in the quantity demanded. All right. People aren't going to just suddenly move out of their places overnight. All right. Over time, the demand curve gets lower. The slope of it gets flatter. All right, and people are able to respond more quickly to. People are able to respond over time, I should say, to the changes in the price of housing. And then again, if you look over a longer and longer horizon, over the course of a year or so, the demand curve is even flatter over that amount of time. All right, and there is a bigger change in the quantity demanded over that amount of time. This should, of course, extend all the way up to the demand curve. One last thing I want to mention here is the relationship between slope and the demand curve. All right. So notice that the flatter the demand curve gets, the more elastic demand is. But elasticity and the slope of the demand curve are related, but they are not the exact same thing. In fact, with a linear demand curve, the slope will be the same at all points. But the elasticity is different at different points on the same demand curve. All right. Elasticity decreases. It gets more inelastic as you move down and right along a demand curve. So if this is the demand curve, the slope of this line stays the same, but as you get toward the edges, all right, the demand there is more inelastic. All right. So here is the demand curve. Here are some prices. Let's take a look at different prices and the quantity demanded at those prices. So down here toward the bottom, we are highly elastic. The slope is the same, but if you were to calculate the elasticity of demand for a change from 5 to 4, you find that it's negative 9.1. All right. If you were to change the price from $1 to $2, changing the quantity from 4 to 3, you find that they're less elastic than here, but still relatively elastic. Here, if we change from 2 to 3, notice we get a drop from 3 to 2 in terms of the quantity demanded. That's unitary elastic. The percent change of the price and the percent change in the quantity demanded are the same, unitary elastic. Up here, though, it's relatively inelastic. All right, so moving from 3 to 4, moving from a price of 3 to 4, you get a smaller relative change in the quantity demanded, and up here we're highly inelastic. So it just depends on where the market is, which will mostly be determined by where the supply curve is. All right. So moving down and to the right makes you more elastic. So I'm going to leave you with this clip from the movie Jingle All the Way. It's about a dad, Arnold Schwarzenegger. We let him be governor once, and he's looking for a toy called Turbo Man for his son, and it's very close to Christmas. All right.